Hey guys, so in this video, we're just going to look at how to create a linear regression equation, use that equation to predict values, as well as determine the correlation of your data given a table of values. So for this first question, it should be nothing new because it's stating to write the linear regression equation for this set of data, and then you're rounding all your values to the nearest thousandth. So with any problem that tells you to write a linear regression equation, we want to use our calculator and the stat feature. So in L1, we're typing in our x values. In L2, we're typing in our y values. To save time, I already typed in that information. When I hit stat edit, you'll see that all my values are there. Just a reminder, you need to use every single value that they give you in your table, or your equation will be affected. So once I type in all our values, I'm going to hit stat, over to calc and choice 4 because it did state linear regression. Your work is copying down what you see in the calculator. So we're going to copy down the equation y equals ax plus b, our a value, and our b value. From here, we're just going to substitute in our a value with 17.159x, and then our b value, which was negative 2.476. From here, it says using this equation. So what I want to do is bring down the equation that we just came up with because I have to substitute values into there. It did state to predict the slope of the beach. If you're predicting something, you don't know that something. So the slope of the beach represents your y. So we're looking for y. And we know that the median diameter of the grain of sand is 0.65. And we know that represents our x value. From here, I'm just going to take 0.65 and replace it with the x that I see in the equation. And I'm going to type that right into the calculator. So 17.159 times 0.65 minus 2.476. And when I enter, I get 8.67735. It did state for this part to round to the nearest tenth. So I'm looking at the second number after the decimal. It's a 7, so I'm going to round my 6 to 7. So our answer is 8.7. For the next part of the warm-up, we're just discussing and looking at what we talked about in a previous video, which was causal relationships, and that's dealing with your correlation. So for the following three, we want to tell whether a correlation is likely in the situation, and then if so, tell whether there is a causal relationship, which just means is there a cause and effect. So for the first part, it's saying the amount of time spent talking on a cell phone and the remaining battery life. This is going to be a negative relationship or a negative correlation, because correlation is just like a relationship. And the reason being is it is a causal relationship because the more you talk on your cell phone's battery will decrease. So as one is increasing, the amount of time spent on the cell phone, the battery life is decreasing. For part B, it's saying the number of hats you own and the size of your head. This is going to be no correlation. And the reason being is because they have little to nothing to do with each other. And then for C, it says the age of a toddler and the size of the toddler's vocabulary. So this is a positive correlation. And the reason being is because as a toddler gets older, their vocabulary will tend to increase. So yes, it is a causal relationship. So this next section that we're going to look at, how to turn your STAT diagnostics on, is super important, especially if the question is telling you to find or state the correlation coefficient. So in order to get your correlation coefficient, you must make sure that your STAT diagnostics is on. What I would recommend, when they clear your calculator the day of the Regents or the day of the test, what you want to do is go to Mode, scroll all the way down to STAT Diagnostics. It's automatically going to be set for off. We want to turn that on by using the right arrow and hitting Enter. From here, you'll see that it is on and we could get out of that screen. By turning your STAT Diagnostics on, when we pull up our linear regression section, we're going to be able to see our correlation coefficient pop up on the screen. And that correlation coefficient, again, is indicated with the letter R. So let's look at the next example now that we turned our STAT diagnostics on. So for exercise 1, they're giving you a table and they want you to state the linear regression. So just like the previous problem, we're going to type all those values into L1 and L2. So I'm just going to pause the video to save some time. Okay guys, so I just went to Stat Edit and I typed in all my values. From here again, it does state to find the linear regression. So we're going to hit Stat Calc 4 for linear regression. Enter, enter, enter. Now you should see 2 more things pop up on your calculator, and those 2 things came from turning your STAT diagnostics on. The R-squared value we are not looking at this year. That is related to a percentage with variance. Again, not responsible for that this year. The important thing that we need is that R value at the bottom. We're just looking at the single R right here. So I'm just going to copy down what my calculator is telling me for the work. So we have y equals ax plus b. A equals negative 50.2638889. B is 6182199074. So the question does state to round to the nearest integer. So for here, instead of doing y equals, they want us to use f of t equals, and instead of x, we're going to use the variable t. And then in your table, you should see what they're using. So t again is x, f of t is y. So rounding to the nearest integer, we're just going to write negative 58t and then plus 6,182. So part A is complete. And then part B says, state the correlation coefficient R to the nearest hundredth. So our work is just writing down what we see. And again, our correlation coefficient is just the singular R, not R squared. And then the second part of this question says, does R indicate a strong linear relationship between the 2 variables, and to explain? So in the other video, we did discuss that the closer you are to a positive one or a negative one, the stronger the relationship. So we can say, yes, the R value represents a strong negative relationship since it's close to -1. And then the second example, they told us just for part A to write the correlation coefficient for the line of best fit. And then part B says, explain what the correlation coefficient suggests in the context of the problem. So for here, we don't really need an A and a B value, but we still need to put the first column in L1, the second column in L2, and then hit Stat Calc 4. Again, I'm just going to pause the video and type those values in and bring up this screen that we would see on the right. So now that I typed my values in, I'm just going to hit Stat again, over to Calc, and option 4. For part A, it does state write the correlation coefficient. So I'm going to copy down my R value. R equals 0.9422330,559. It says round to the nearest hundredth. So my correlation coefficient is 0.94. For the second part, instead of writing it out, I'm just going to explain what it means. So explain what it suggests in the context of the problem. So that 0.94 is just basically stating that the line is a good model, it's a good fit, which shows as the calories increase, so does the milligrams of sodium. So there is a strong relationship because the 0.94 is close to 1. And again, it suggests that as the calories of beef hot dogs increases, so does the milligrams of sodium per beef hot dog. All right, I just hope you guys stay healthy during this time. See ya.